just going to present on one of the outcomes of my PhD project, which is trying to understand the stream habitat template to help inform stormwater management in urban catchment. So it is widely recognized that urbanization impacts the catchment hydrological processes by reducing evapotranspiration and infiltration, which means that when it rains, most of the water quickly turns into surface runoff because of the increase in impervious surface area. And traditionally, this surface runoff is managed by using hydrologically efficient stormwater drains that quickly transport the water from the catchment into the waterways, the surrounding waterways that is draining the catchment. And these studies have shown that this results in the alteration of the flow regime in the waterways, where the streams or the rivers experience higher and more rapid peak discharge, as well as reduced base flows compared to the pre-development stages. And this results in the channel being modified as well with time, where it's the variability or the diversity of the morphology is affected, where the channel become plain and simplified. So typically, stormwater management, trying to understand the pathway of the degradation of the stream or the waterway ecosystem, is by trying to just connect the mechanism, this pathway of trying to understand the flow alteration and directly connecting it to the ecosystem functions that they observe. But what my studies or my PhD project is trying to understand is that by just connecting the flow metrics or trying to just connect the flow alteration to what is observed at the ecosystem function, you ignore the role of the channel form and the morphology in trying to impact the role of the flow with the ecosystem functions. So what I'm trying to understand is that how can we use ecohydraulic modeling or ecohydraulics investigation, which will try to combine the interaction of the flow with the morphology to be able to kind of explain the functions or the ecosystem functions that is observed. So the key research question is to try to understand or try to investigate the extent that urbanization impact have on the stream hydraulic conditions. And with this, I use 2D hydraulic modeling to help characterize the hydraulic condition in the urban reach and also compare it to a natural reach within the same. So I selected 2 steady reach, one within the same catchment called the cardinal catchment. So one of the steady reach is upstream of the catchment, which is within a forested region. And the urban site is within the built area within the same catchment. And I did surveying of the reach to be able to get the topographic features for the 2D modeling, and also measured the stream flow. Then I use 2D hydraulic modeling to be able to model the hydraulic conditions. So I selected multiple ecohydraulic relevant metrics, but for this presentation, I'm just going to talk about shear stress, which try to characterize the bed disturbance, the channel bed disturbance, and also use slackwater habitat areas to also try to characterize the physical habitat availability within the channel. So what we found was that for the urban sites, the frequency and the magnitude of channel bed disturbance were predicted to be substantially high, which means that when you take for a flow regime within for an annual flow regime, the amount of time that the channel is potentially the bed is potentially being moved was found to be substantially high at the urban side as compared to the natural side, which kind of supports the idea that the channel is, the stream is getting so much inputs from the stormwater, which means that the channel will experience high flows or high storm flows within the year as compared to the natural flow regime within the urban side. And also, we try to characterize the area or the percentage area of the wetted channel within the reach that is experiencing potential movement. And we found out that within the urban channel, the proportion of the bed that is experiencing mobility increases a lot, even at flows 0.5, less than 0.5 of the bank full, as compared to the natural side where the channel, even up to the bank full, we experience just a few percentage of the proportion of the wetted area that is being moved. And if you also look at the spatial mobility distribution, what we found was that because of the high diversity of the topographic features of the channel morphology at the natural side, the morphology is able to steer the flow even when the channel experiences high flow because of the variability. It's able to steer the flow in such a way that the spatial locations of the channel that is experiencing high bed mobility changes with time as the flow increases, as compared to the urban channel where the variation of the spatial location does not change but just extend longitudinally and laterally within the channel. And with concerning the slap water habitat area, what we've also found was that the rate at which the total area of slap water that gives or produces some kind of refuge within the channel reduces or plummeted a lot within the channel compared to the natural site. And we found out that the total area, the frequency of the high total area of slap water habitat that gives some kind of refuge for biota reduces a lot, has reduced a lot at the urban site, which is kind of skewed more at 100 to 200 meters square annually compared to the natural channel that kind of have a lot of diversity within the channel. Also, we realized that the topographic variability at the natural reach also encourage more surfaces being inundated with our slap water habitat area, even as flow increases as compared to the urban channel. So, in conclusion, what I proposed was that the hydraulic condition in the urban stream have been substantially altered, which can help stormwater management to understand the physical mechanism that lead to ecosystem degradation, as compared to them trying to just connect the flow alteration to the ecosystem degradation. So now this kind of gives us a mechanistic pathway that can help them to be able to model the different hydraulic conditions within the channel. And it was found that the bed disturbance was higher, with the area of channel bed likely to be mobilized about 4 times compared at the urban side compared to the natural side, and habitat availability plummeted rapidly at the urban side. And this result highlights the important interplay between hydrology and geomorphology, which brings in the ecohydraulic aspect of trying to manage urban streams rather than just looking at the hydrological perspective of it. So what does this mean? The altered hydraulic condition could be a key limiting factor driving stream degradation in urban catchment compared to many of the studies that have been done in Melbourne, Australia, where normally they just connect it to water quality and also just flow metrics. And propose that management efforts should further optimize in a way to meet required hydraulic condition. So instead of just trying to manage stormwater, just to get the natural flow regime, they should also consider the role of the channel morphology, which brings in the idea of ecohydraulic modeling. And stormwater management and protection of stream ecosystem process should also incorporate the anticipated effects on the stream hydraulics. So, which means that the management strategies that are implemented should have an objectives that are directly linked to the needs of the stream instead of just trying to achieve a required hydrology. Thank you very much. And if you want to know more about this, this work was published earlier this year in the River Research and Application. So you can have a download and read more about this research. Thank you very much.